Okay, welcome back to another mini math discussion. In this discussion, I am going to do two examples, one with adding rationals and one by subtracting rationals. Now, a rational, again, is a glorified fraction, which means you have to follow your fraction rules. Your fraction rules, or the biggest one, is that you must have a common denominator in order to add together. Well, in this case, when we're talking about rationals, we are talking about a fraction that is made up of expressions, and those expressions are either single, meaning they are just a number or just a variable, or they could be made up of expressions, meaning multiple terms, or they could be made up of, within those expressions, they could have binomials, which are 2 terms, trinomials, 3 terms, etc. So they can be as big or as little as possible. And what you have to be able to do is you have to be able to find a common denominator, usually in the form of an expression. So with just straight fractions, normally you would have to say find your least common multiple. So you'd be looking for a single number or a single variable that was in common with both. When we're talking about rationals, we could very well be talking about binomial or trinomial expressions. And so the rules are going to be exactly the same as using normal fractions. So if you see here, first we have addition, and so notice I have one rational. It's got binomials on top and bottom, and I'm adding it to a second, but what you should notice is that these two denominators are different. So I have to find a least common denominator between the two. So I have to look at the first fraction, and my first fraction, or rational, has x minus 3 in the bottom. My second one has x plus 3. Therefore, my common denominator has to be the multiplication of the two. So normal fraction rules would say whatever you have to do to the bottom, you have to do to the top. So if you look at this first rational here, I have the x minus 3 part already. What's missing is the x plus 3. So this is going to become x squared plus 1 times the x plus 3 all over x minus 3 times my x plus 3. And I have to add that to my other. So if you notice the other, I already have the x plus 3 on the bottom. So my top is going to be the x minus 5 times x minus 3 makes my denominator the x plus 3 times x minus 3. So addition rules say you have to add across the top. So this is going to be x squared plus 1 times x plus 3, and I'm adding this to the x minus 5 times x minus 3, and it's over my single denominator, x minus 3 times x plus 3. At this point, you have to be able to reduce. So the name of the game is always to reduce as far as you can. And so here, when we're doing that, what that actually means is that first I have to FOIL these two together. I then have to FOIL my other two together, and then once I've done that, I have to combine like terms. So in this case, I'm reducing by combining my like terms. So if I look at this first one, remember FOIL says first, outer, inner, last. So I have x squared times x is going to give me an x cubed. X squared and 3 is a plus 3x squared. Then I have plus x plus 3. And I'm going to add this to FOILing of the back half. So this is going to be x squared. And then I'm going to have a minus 3x minus 5x plus 15. And this whole thing is still over that least common denominator. I have to keep going. So now I have to be able to combine my terms. So I have x cubed plus 3x squared plus my x plus my 3. I would distribute my positive through so nothing's going to change. So this is going to be plus an x squared minus an 8x plus a 15. So I have to look at what are the terms that I'm going to combine. Well, I have a 3x squared and an x squared. I have a positive x and a negative 8x. And then I have plus 3 and plus 15. So when I'm doing that, I have to be able to combine my terms together. And so here, this is going to give me x cubed. And then I have 3x squared plus an x squared gives it plus 4x squared. I have x minus 8x is a minus 7x. And then I have 3 plus 15 is plus 18. And this whole thing is still over x minus 3 times x plus 3. Now, that being said, you could leave this like this because there's nothing else that we're going to be able to do that is going to reduce down. But the other thing that we could do is you could go ahead and FOIL the bottom together. So depending on what you're doing, you could leave it as is, or we could rewrite it so that I have x cubed plus my 4x squared minus my 7x plus 18. And in this case, the whole thing would be over x squared. Outer is going to be plus a 3x minus a 3x minus 9. My middle here is going to totally disappear. Leaves me with x cubed plus a 4x squared minus 7x plus 18 all over x squared minus 9. So that is an example of adding my rationals together. So the next example I wanted to do is an example of subtraction. So in this case, I have these trinomials here. So the first thing that I want to do is first you need to factor each denominator into the parts. The second thing you need to do is you need to find your lowest common denominator. And then the third thing you need to do is you need to go ahead and do your subtraction. And by that, what we mean is here we are essentially following your fraction rules. So I have x squared minus 8x plus 16. So I need to break that into its factors. So I'm going to have 1 factor, 2 factor. My x squared is going to break into x and x. My back sign is positive. My middle sign is negative, means I have negative, negative inside. And then I need factors of 16 that give me 8, so this is going to be 4 and 4. Now I have to do the other. I have x squared minus 3x minus 4. Again, I have to break it into its factors, so this is going to be x and x. My back term is negative, means I have one positive, one negative, and I need factors of 4 that are going to give me a negative 3. Since my middle term is negative, the bigger factor is negative, and the only combination there is going to be negative 4 and positive 1. So I have to rewrite my rationals and put the proper breakdowns underneath. So I have 9x, and underneath that is going to go my x minus 4 times my x minus 4. And I am subtracting away my 7x, and underneath that one is going to go x plus 1 times x minus 4. So here I have to be able to identify my least common denominator. So I have to look at what do I have. Well, under my first rational I have 2 x minus 4's. Under my second rational I have 1 x minus 4 and an x plus 1. Therefore my least common denominator has to be x minus 4 times x minus 4 times x plus 1. Okay? If you look at the first rational, what's missing is just simply the x plus 1. So this is going to be 9x times x plus 1 over x minus 4 times x minus 4 times x plus 1, and I'm going to subtract away the second. So this is going to be 7x, and if you look here, I have the x plus 1 and I have 1 x minus 4. I need to add a second. So this is x minus 4 over the x plus 1 times x minus 4 times the x minus 4. What I have to do here is I have to distribute through my upper binomials here. So 9x times x is going to give me a 9x squared. 9x times 1 is plus 9x. I have to subtract, and in this case I'm going to open myself a little bracket or parenthesis because I'm not ready to deal with the negative yet. I just want to distribute 7x through. So this becomes a 7x squared, and then 7 times a negative 4 is negative 28x. And this whole thing is over my common denominator of x plus 1 times x minus 4 times x minus 4. I now have to take this negative and I have to distribute it through my fraction here. So this is 9x squared plus my 9x. Distribute the negative through, makes it negative 7x squared plus 28x, which is all over that lowest common denominator. And then the last thing I need to do is I need to combine my like terms. So I have 7x squared, or negative 7x squared and 9x squared, and then I have a 9x and a 28x. So I have to combine those together. 9 minus 7 gives me a 2x squared, and then I have 9 plus 28. So here my 9 plus 28 is going to give me plus 37x, and this whole thing is over x plus 1 times x minus 4 times x minus 4. And if I wanted, about the only other thing that I could do is across the top I could pull an x out. So you could either leave it like this, or we could go one further. You could pull out an x, which leaves a 2x plus 37 on top, all over x plus 1 times x minus 4 times x minus 4. So either one of these would give you the right answer. Since there is nothing else that can cancel or simplify or reduce any further, you have completely finished. So there you have it. You have one example of adding your rationals together and one example of subtracting your rationals. As long as you remember that to add or subtract rationals is the exact same method as adding or subtracting fractions, you should be fine. If you have any questions, please let me know. Otherwise, remember, keep smiling, ask tons of questions of yourself, or colleagues, or friends, or classmates. Make sure that you have lots of fun while doing your math, and relax. And above all, I'll see you next time.